Hello geographers, this is an A-level presentation which is going to look at one case study in coastal systems and landscapes, and it's a case study of coastal environment at local scale to illustrate and analyse fundamental coastal processes, and its location is obviously Barton on Sea. And it fits in across the whole of the specification. And you can see that you would look here at systems and processes and the coastal management that is being used there to try and reduce the impacts of these processes on the landscape. So Barton on Sea is a clifftop village in Christchurch Bay in Hampshire in the south of England. And you can see its location here on this UK map, and also where it sits in relation to the city of Bournemouth. So it sits east of the city of Bournemouth, very close to the Isle of Wight. This shows you Barton on Sea and the sediment cell. So you can see Barton on Sea, east of Highcliffe and Mudford. Hengretsby Head is here with the harbour. Just to the west of that, obviously, is Bournemouth. You may wish to take a little screenshot of this because it does put it into context where those areas of high population are found and sites of special scientific interest, and obviously the location of sandbanks and the littoral cell. So there are some causes, some reasons why the erosion at Barton on Sea is so high. The rocks are made up of weak sands and clays. They're easily eroded and they give little strength to resist that collapse. The pattern of rocks is permeable sands on top of impermeable clays, which allows water to settle, that should say impermeable, where the two layers meet. Underlying clay of cliff is exposed, which leads to mass movement in the form of slumping. It's got high energy waves. There's a high amount of water saturation in the cliffs, and it has this long fetch, which causes high energy destructive waves. The stretch of the coastline faces the direct force of those prevailing southwesterly winds. So there are lots of effects of coastal erosion here at Barton. So those residential areas that are at risk, there's Barton Court, which is 20 metres from the cliff edge and has been predicted to be lost in the next 10 years. You have an area of residential development, which is 1.8 kilometres long, which is at risk over the next few decades. People will be left without houses, and on average, the recession rate is 1 metre per year, but can be as high as 2 metres. But they are trying to manage this area, and they've been trying since the 1930s when they constructed some wooden groins. And then in 1968, approximately 1,750 metres was protected, costing over £1 million at the time. And it was mainly hard management, so cliff like riprap, revetments, gabions, boulder groins, cliff face drainage. We've been trying to get out the water where the water meets the sand and the clay. There's a layer of slippage that happens there. So using drainage pipes to reduce that saturation and ability to lubricate that area. In 1991, a 1,800 metre rock revetment was built, costing 4.5 metres and designed to last 30 years. We've had some new drains and regrading, and some beach nourishment were established. There's also a shoreline management plan since the late 1990s, which was started in 1995, to move towards a more sustainable form of management, looking at the littoral cell overall. And in 2006, feasibility studies were carried out by the New Forest District Council to introduce a new technology of siphoning drainage pipes to reduce that cliff recession at central Barton in a more sustainable manner, since earlier measures had not obviously solved all of the problems. And you can see some of those management techniques. Again, take a screenshot of this image. And it shows you those that happened in the 1960s and 70s, those that were started in the 1990s, and what's happened since in the turn of this century. So one exam question that you could have a go at is assessing the relative importance of weathering and erosion in the development of coastal landscapes. So using this as a case study to back up your ideas around weathering and erosion. And the way that you could do that is here. So this is an example of erosion and weathering working together in the process of cliff collapse. The cliffs are composed of gravels, sands and clays. This means that they're easily eroded and have little strength to resist collapse. The gravels and sands being permeable created a slip plane. They absorb rainwater, whereas the clay is impermeable. This combined with the undercutting caused a rotational slump and cliff collapse. So the concept of landscape should emerge in responses here, reference to individual landforms rather than the assembly of landforms associated with landscape development is likely to be a feature of lower end responses. So being really specific with the use of your case study material. Have a go at that question, pause the video here, and then you can compare it to the mark scheme, which is coming up. So your mark scheme, have a look at your answer. Try to highlight any assessment objective 1. So where you've shown really good knowledge and understanding using those key bullet points there. Remember, that's worth 10 marks. Have a look at AO2. What have you discussed in your AO2, your assessment objective of application? Give yourself a mark out of 10 for that and combine the two together. The examiner's comments that were made about this in 2018, that obviously it is a very strong physical geography dimension. Those who understood the difference between weathering and erosion were in a strong position. So weathering happens in situ and erosion includes the removal of that material. Provided you could apply this to different landscapes and explain how these processes contributed to the landscape formation, you're in a strong position. A number could not distinguish between those processes. Finding credit in this situation was difficult for the examiner. Place reference and detailed support was generally not strong, though case studies such as Holderness did emerge. Some students did consider the relative importance of these two distinct processes and then considered dispositional processes and the role of human intervention in coastal processes. Have a look at your answer. How can you improve it? It may be that you need to really go over and revise those processes of erosion and weathering again, and then apply those to Barton. Good luck.